Okay, in today's problem, what we are going to say is count collision on a road. So it is Leetcode problem number 221, sorry, 2211, and this is today's take problem. Now let's read out the problem description. There are n cars on a infinite long road. The cars are numbered from 0 to n minus 1, from left to right, and each car is present at a unique point. You are given a zero indexed string directions of length n. Directions I can be either L or S, denoting whether the ith car is moving towards the left, towards the right, and staying at its current point respectively. Each car has moving car has the speed, has same speed. Okay, the number of collisions can be calculated as follow. When two cars are moving in opposite direction collide with each other, the number of collisions increased by 2. When a moving car collides with a stationary car, the number of collisions increased by 1. After a collision, the car involved can no longer move and will stay at the point where they collided. Others, other than that, cars can change their state of direction of motion. Okay, so return the total number of collisions that will happen on the road. Okay, so this is the problem. So what they give, they given string. The given string. So in the string we will be having an characters. For each character it denotes, each character is considered as a car, and the character denotes the direction of the car. So if it is R, it is moving towards its right, and if it is L, it is moving towards its left, and if it is if it is S, it is not moving anywhere. It is at a stationary point. Okay, so now let's try out this example. So they have given this. So when it comes to R, so it is moving towards its right. When it comes to L, it is moving towards its left. So let's consider a car of 0 is moving towards its left, and a car of left has been coming towards it, and they collide each other, and hence the two cars are at motion. So the number of collisions here for R and L is 2, and if you go for, and this R and L becomes S. So now let's have this R L R S L. So this is the this is the given string. So now this car moving towards right, and this car moving towards left. So now these two cars collide, and this will become S, because once they collide they will become S. So the number of collisions here is 2, right? And after this the car is moving towards right, and there is a stationary point. So it is moving towards its right, and there is a stationary point, hence only one car is moving, one car at the motion. So will be this R and this S will collide, and this will become S, and the number of collisions will be increased by 1, and it becomes 3, because only R is at the motion, S is not at the motion. Now so there is a stationary point, and there is L. So if you calculate this, so this and L and S will collide, and only L is at motion. So this will become 4, and this L will become S. So it collides with the stationary point, and it becomes a stationary point. And for this L, this will become the same. So this will collide with the stationary point and becomes a stationary point. So which is 5. So now 5 is the output, right? And let's take this example. This is LL or R. So when it comes to L, the direction of L is, so the direction of L is, so it moves towards this direction. When it comes to direction of right, it moves towards this direction, right? So these right cars will be moved towards this, and it won't encounter any left or stationary cars, and this left cars will move towards this direction, and it won't encounter any right or stationary cars there. So the number of collisions here will be 0. Okay, so this is what we do. So what we do is we have a string, and we need to calculate the number of collisions. So hope you know understand the problem. So now we'll see how to approach this problem. So they have given a string, and let's see if at the leftmost of a string, if you have a L, you can ignore it, because it will move towards its left, and it is not going to collide with any of the given it is not going to collide with anything, and it is not going to change the value of collision also. And at the rightmost end, if you have r, as much of r you have, so those will be like moving towards right, and it is not going to collide with anything. So now what we can do is, now let's write in condition for that first. So int n is equal to direction dot length, right? And okay, you can say this as j. Let's have this separately. Okay, then int I is equal to 0 and int j is equal to n minus 1. Now what we have is the two endpoints of the given string. After that, while I is lesser than n and directions dot caret that I equals to L, what we can do is we can increment the I count, which means if the leftmost characters, if they have a character of L, we can ignore them because it is not going to collide with anything. And the same will be done for rightmost nodes, which is while j is lesser than greater than or equal to 0 and direction dot caret j equal to or, then we say j minus minus. So we are now what we have done is we shorten the given string. So we remove the leftmost L characters and rightmost uh, R characters. Okay, then after what we do is we have a int collision. So this will calculate the collisions for us, and what we do is for int, let's consider this k is equal to I, k is lesser than or equal to j, k plus plus. So now what we are doing is we omitted those characters and we are only iterating through the substring which has the possibility of collisions. So when does that collision happen? So we ignore the cars which are not going to collide. So what it means is each and every car in our substring is going to collide now, right? So it is not going to collide. So for if left and right both collides, what happens? The collision value will be 2, and if left is colliding with S, we get 1, and R is colliding with S, we get 1, right? Which means for each L and R, the collision will be increased by 1. So if it is L and R are colliding, it will be 2. If it is only L colliding with stationary, we get 1. If it is only R colliding with stationary, we get 1. So what we can do is we can directly iterate through the string of a substring which we have now. We can iterate through that. For each L and R, we can increment the count by 1. So like what we can do is let's have the character first. Character C is equal to directions dot caret that k, and if that C is equal to L or C is equal to R, we can increment the collision, so which is collision plus plus, right? So if the iteration will be started, and if you encounter L and again R, what happens is for L it will increase the count, and for R also it will increase the count. So if L and R are both are colliding, it will be 2, and if it is only L and S, for L it will increase the count, for S it won't increase the count, and for R and S are colliding, for S it won't increase the count, for R it will increase the count. So that's how for a moving car, if it is crashing or colliding with the stationary point, we will increment count by 1, and if it is if both moving cars are colliding with each other, we will be incrementing the count by 2. So here we can do some other changes also. So what I have done is, either if it is L or R, what we do is we are incrementing the count. So here we can say if it is equal to yes, then continue, which means they have mentioned, so for sure there will be only 3 characters in the given string, which is L, R and S. For L and R we need to increment the count by 1. So for S we don't want to. So what we do is we check whether the character is equal to S. If the character is equal to S, we continue, we won't increment the count, or else it is going to be L or R. For that we will be incrementing the count. Okay, so now let's see, and we are going to return the collision here. Now let's run this. Let's submit this. Okay, so that's for this video. So if you like the video, do share, comment and subscribe. So and for more videos like this, check out our channel. Okay.